Yeah, hi everybody. It's really crowded. I didn't believe that we have really so much people here. So my name is Jörn Seger. Sometimes you will find me as Yorn in some development environments. Um, I am a software developer, and I do daily software development. Yeah, with a lot of people together. For example, actually with the Thermomix TM6. And what I wanted to focus on today is the dark mass. Yeah, it's not. I don't think that it's often used badly. So yeah, with a bad shape. But what I want to do is to explain to people which are not so familiar with C++, what or who wrote C++ in the, I don't know, 2000 or something, and didn't catch up with all the stuff that is now available in C++ 11, in 14, in 17, and something like that. And so I hope I don't bother you with that. So you might be all experts. I'm sorry for that. Therefore, for you guys who are experts, I want to have another motivation. I did that yesterday. So who has the chance to listen to my lightning talk yesterday? Okay, just few. So keep calm, yeah, please. I wanted to show you something and to give you or give the experts the idea of what the problem mostly is in software development and working with people who are not that involved in software as the experts are. Yeah? This is a tree. Yeah? I take an analogy from biology. This is a tree, but most of us know what the material is of a tree, but we don't really puzzle it together. And so what I wanted to give you as an example is that what is the material the tree is made of? It's made of wood, right? It's made of what is wood? It's carbon somehow. Yeah, where's the carbon coming from? Yeah, you learn about something like photosynthesis. Yeah, and you learn about leaves and light and photosynthesis. But what is the material? The material is what does the leaves use for making the material? Yeah, it's carbon dioxide. Yeah, that is what is the wood, the material of the tree made of. Yeah, it's air that is made static. Yeah, made material, and that is, we all know all these phases. Yeah, we all know photosynthesis. We all know that's a carbon. That wood is carbon, and we know about trees, leaves, behavior with sun, but we mostly didn't puzzle that together. And that is the idea what I want to focus on here. I have, my lightning talk was a bit longer. I talk about sustainability, that software must be sustainable, that you just not throw away your software, but work on the software that it's, in the end, is good software even for the next generation. Yeah, so that we have something like a nice place, not a bad place in the end. So, okay, let's get started with the puzzling. And so what I wanted to start is really, because it's the last at this place, it's the last presentation. So I'm gonna start with a really easy example, hopefully. So with code. What I wanted to show you is C code. Yeah, okay, I forgot. No, I don't forgot, but it doesn't make sense to present everything here. There must be include C and stuff like that. But I use this C handler in C++. It don't care about what the C handler really is about. I just use something like a char pointer and a size and something like that. I use, but we have some interesting, not methods but functions here. We can create a handle, we can free a handle, and we can do something with this handle. So that is the starting point. Yeah. Who knows this kind of software? Mostly from C. Yeah, a lot of people, I think. So how would we use this in an C++ environment? Yeah, the first thing is that we start in a very old way. Yeah. I wanted to start with that here. So what do? We create a handle, we make create handle, get a pointer back and put the pointer into something like this handle pointer, and we work on that handle. That is how we use it traditionally, but this is C, right? This is not really C++. So okay. So what will we do when we use it in C++? Yeah, we want to have something like an object A and do something like A in it and print and stuff like that. We want to wrap that away. Yeah, we want to wrap all the nasty things from the handling or from the handler to an object. Yeah, so what do? I use here object old, because I wanted to show that this is really an old object. So what do? We create something like this. I can. Yeah, and that is what we traditionally do in C++. Yeah, who knows kind of this? Most people do this traditionally with objects. Yeah, do you agree? Who would not agree? Who would agree? Yeah, okay. So that's very traditional. Yeah, so, but again, with this old pointer, we do something like, okay, we have that again, and we can compile that, run that, it works. Yeah, so nothing bad. So, but when I really must care for the names, it's a bit tricky. So, but when we have something like this here, what will happen here? Some ideas? Is there something evil? Oh, shit. Holy mess. Yeah, there seems to be something wrong here. So, yeah, okay. That is the code from the main. What's going wrong here? Yeah, okay. Yeah, something. It seems to be something here. Yeah. Okay, that is evil. Yeah, because we assign. This is an assigning. Yeah, we assign A to B, and B the object A does not have defined a signing operator. Yeah, so what does the compiler does is just copy whatever there is from A into B, and B is and A and B share the same pointer, and that is a completely correct answer. So if we look here, we call handle free with the same handle 2 times. Yeah, that is ugly. Oh, I'm sorry. So what is the idea? How can we do this in a better way? Yeah, we can go for smart pointers. Okay. You may know smart pointers. Do you? Who knows smart pointers? When I show this, yeah. Everybody knows what's happening. Yeah. I do a unique pointer from this handle. I always use the same handle. Yeah. I don't care about the handling because the library behind is not in my scope. I don't have any chance to change anything here. But I have the header, and I just use create and delete within this unique pointer. Yeah, I can define a delete strategy as well. Yeah, most of you might know. And then I can do mostly everything I did before. Yeah, I also I don't have any wrapping. Yeah, I use the same handle set data from before. Yeah, from the handle. But the only advantage I have, or the only advantage I have, is creation and deletion. But I need to use get for getting the pointer. Yeah, I want to get the handle, but the handle is controlled by unique pointers, and so I use get to get the pointer. Yeah, that is much better, but not. Yeah, it feels a bit like C++, the stuff that is yeah somehow mixed together. So what we can do is we can make it better. Yeah, hopefully. And what we wanted to do is we wanted to have something like, I have another, I use another keyboard. I guess. Okay. What I want to use is something like this. Yeah. Again, that's the same as before. Yeah. I wanted to have an object, want to init, print, and whatever, and wrap everything else away. But now I use object.h, not old object or object old or whatever. So there seems to be a difference. So what is this difference about? Difference is I put here, I use the unique pointer. Yeah? What I use is object A does not use the handle as before as a pointer and using free and create, but we use the unique pointer in the sense as it's meant to, but we wrap it away from the user of this object. So what we have here is something like an advantage for the user of this library. Yeah, we put a wrapper around it. And what we are, I'm sorry, I'm too lazy and I'm too slow. And we use the handle, or the handle can be used as a Boolean operator, Boolean information, if this handle is really available. Yeah, so that we can really care that we don't delete any other things here. We don't delete any copy operators or assigning operators and things like that. So there might be some issues here. I always wanted to be sure that handle is really available. Okay, and then hopefully I'm done. And again, what do we have? Smart pointer. And then we can do the exact same as before, as you remember, but with object.h, with this new object. I create object A, object B, do some initialization. I don't care. Yeah, it's just initialize some sort of array, char array, and we do use the assigning. But nothing changed here, more or less. But what do we see when we compile that? Yeah, it doesn't fit on the screen. But what does this say here? Do you have an idea? What is happening? The compiler said to me, "Hey, you can't assign A to B because you use a unique pointer and you don't have any. For the unique pointer, we have no assigning operator. That is deleted. Yeah, it's forbidden to use a assigning operator within object A that is used here for unique pointers. So here I'm much safer. Yeah, and that is the reason why we use unique pointers. There are a lot of other reasons. But to make our life easier for getting errors in runtime, but understand that we have this in compile time. It's fixed, that we can fix it in compile time. So, okay, what can we do? We can think about that. Why do we want to assign A to B? That is an architectural question that we need to solve here. Yeah, and we can say, okay, we wanted to move. That is not forbidden. Yeah, for a unique pointer, we can move A to B, but on what cost? What is the idea of moving A to B? Yeah, what will happen with A if we do this? A will be lost. There is no A in the end. Yeah, A is completely moved to B, and B is the only one who will carry the information, and A is free of anything. Yeah, A is something unusable. Yeah. So when we compile that, you'll see we create both handles, we set all both handles, and then we do this assigning from B to A to B, and we see, aha, then the program is doing the right thing. It frees one handle because one information is lost, yeah, because of the move operation. And then we can print A. We try to print B, but our handle is, as you remember, the Boolean operator for the handle. We only be able to print A, and in the end, we will free this A handle at the end of the scope. Okay? Everything's clear? Any questions here? No, this move does not contain any change in the question. Thank you. The question was does it change memory, right? Something like that. Yeah. So what happens with A when we do a move? Okay, I'm completely lost in time. I see. Okay, maybe we can clarify that later. But A is this move is just saying something like B is now A, and A, if we do this, A is nothing. That is the idea. Yeah. Question is, all memory is accessible? No, there is no second memory. Yeah. So that is the thing. This one. The question is, what is this line, right? So the print, when you remember, we have this object, we do print, and only if this handler exists, if this is true here, then we do a printout. Yeah. Therefore, there's no printout because this handle is not there anymore, because B, the thing is, B is lost. Yeah. And A is transferred, or kind of some kind of a pointer assigning. Yeah? A is then handed over. Okay. Oh, I'm sorry. I think we need to go further here. I wanted to say so much for ASIO, so I'm. Second thing is but I think it's important. Yeah. Second thing is wrapper. Yeah, we have so much wrapping in embedded systems and with C headers, or maybe C++. Yeah. So what do we have? So we have one header file that is saying something like this. I put just an output here. Yeah. So don't care about that. We have some device. There's a device, and we have a public method that says enable, disable, and we have much more, whatever. Yeah, but this is the only thing we are interested in. Yeah, and what we have else is another handler, other enable, and this is really a hardcore C header. Do write device with some enum stuff. Yeah, and we would just want to disable, enable XY or AB with some magic numbers. Yeah, and this is what we are faced with. But we wanted to grab everything together and write something like a wrapper that hides all this nasty stuff. Yeah, and what do we do usually with that? What do we do? Yeah, traditional. We do abstract base class, write some virtual function, enable, virtual disable. We derive classes, enable hardware 1, enable hardware 2, do some enable, disable functionality into that, and we don't need to forget. Yeah, we need to include. So there's an association. We need to include this first header, and here we need to include the second header. And what we should not forget again is my class. I wanted to use it somewhere. Yeah, so my class is want to use this abstract enable disable function that we need to write. Or isn't it? I think so. So, but what I wanted to teach you, or to open your mind for, is this is I call this Java code. Yeah, this is the yeah, whatever. Something, for me, it looks a bit old-fashioned. Yeah, what could we do else? Yeah, it would be really nice if we just have a weak association between my class and this header and this header. Don't create some difficult what objects and put this object somewhere. We don't like that. Yeah, we don't want a strong coupling, or we want a we want a weak coupling, and we want to have something like add, enable, and disable. Can you follow me? Are you with me anymore? Okay. Okay, we had a look at that, and so yeah, let me see. So okay, what do we have here? Yeah, we want to have class E, class B. What is it? And class E use the enable from device A, and B to use the stuff from class B, from the other device, and we want to just call run. Yeah. Okay. How could that run? Yeah. We talk about. I'm sorry. Talk about that before, and yeah, our class should look like something like this run class. Yeah, we want to enable the device, we want to do some fancy stuff, and we want to disable the device. Fancy stuff is just not good. Yeah, but whatever. It could be a lot of stuff. And now, what the hell? How could we enable device A and B and somehow in a quite abstract way? And that is what I would use, something like that. Wouldn't that be perfect if we just have something like class A, set enable disable function, and we just put a lambda into that and do something here. And with class B, we do the same, but with another lambda function with a do write device. Yeah? Would that convince you? Not to write all the classes and enable, disable, whatever, abstract class and deriving and stuff like that. It's not for every case usable, but in this case, just only have two damn functions. This really perfectly makes sense for me. So how would that method, that class A, this my class look like? Okay, what will that be? Yeah, this one. So how would we do that? We would do something like this. We just define a simple function. Yeah, you know this stat function? What we do is just we define the stat function with void as a return value and no input parameters. And if we call run, kann das Ding auch irgendwie pointen? Ja. Ja, also hier. When I wanted to call, I'm sorry for the German. I wanted to call enable function if it's available, and I wanted to call disable function when it's available. And where are they? They are in a private environment and defined as simple func from above here. And I need to have a function that fills these two member variables, these member functions. And that is all we need to do here. We don't need to go bothering with all the abstract classes and derived classes and things like that. That's it. Yeah. Okay? Everybody with me? Okay. I think I use okay too much. Okay? I'm not sure if okay. The question is, is there a penalty for the indirection? Yeah, because we use the function here. A function pointer here. Yeah, there will be a penalty. I think so. Yeah, but I haven't investigated that. So for me, it in most cases this does not really is too much. If you call this hundreds and millions of times, I saw some guys try to evaluate pipelining with boost whatever and with function pointers and things like that. I think you have a penalty, but it's quite low, mainly with this stud function because this is standard. Yeah. Yeah. A good question. Yeah. Yeah. Question is, we use a lambda here, and we need to ensure. That is your question, right? The insurance that this call is always valid, right? Yeah. Okay. This is, I think, clear because this is a static function somehow. This is bound to device here, and we need to give that device in a here we use ampersand. We need to give this to the lambda. So that means when here we are, it's quite easy, yeah, because the lifetime of class A will end here, and the lifetime of the device will end here as well. So here we can ensure that, but this is really important to have this in mind, that you need to have the lifetime of some device somehow be bound to class A. So this is really a simple example. Yeah? So you should think about this is mostly not in main, but in another object. Yeah, and so you need to bind both to the same lifetime. Yeah. Yeah. So the question is, do we have any advantage? Is it correct? Is there any advantage putting the function pointer or the stud function on the stack or on the heap or what? Yeah. Yeah. Yeah, yeah, right. So that is another way to do that, and then, but it looks not so nice as it is here, I think. And yeah, yeah, right. You can do that as well. So you can also use the type of the lambda instead of the function. Okay, so that I planned that only to be the starting point. Okay, but one major thing I had in mind, what I really wanted to tell you is another thing. Some people might know I mostly do something with ASIO, and because I wanted to give you an idea of what is happening with yeah, with multi-threading. Maybe I give you an example here. This might make more sense. You know threads, right? Everybody knows threads. Most of the threads that we write are just main. Yeah, main is a thread. Somehow a procedure, not yeah, it's something that is just doing something and then it ends. Yeah. So mostly it's not really a long task. It's something like compiling or doing some yeah. Therefore, mostly threads are just something, or threads and yeah, forks, processes do something and then they end. What I propose to, if we have to do some more calculation in parallel, I wouldn't really use threading for in most cases, but I would use async and use some futures to get some information back. Yeah, because I saw so many code that is using this stuff and inter-process communication and things like that. For me, yeah, I know this is really controversial discussion, but for me, a thread should stay on its own in most of the time. Yeah, so it should do a calculation or whatever. Yeah, it should use processor power. It should not wait. If we have 10 threads and all waiting, it's completely a waste, right? For me as a developer. Okay, and that is the problem that we mostly see. That we, most of the time, these blue lines, it's waiting for something. Yeah, it's just waiting for events, and that is not, it's not doing something. So we need to rethink about things like that. In this situation, it's okay, but you know this situation. This is a server. Here, this is a guy from here. Here's a web client, and he wanted to see whatever web page. Yeah, he asked the server, give me the web page XY, and the server said, yeah, I can give you, I can hand it over. Opens a thread, and then the guy here contact this thread and gets all the web pages stuff and so on and so on. And this session, this thread, is closed when the requester closes its session. Yeah, you know the situation. Who would implement it that way? Oh, nobody. No. I don't think that anybody would implement it that way. Yeah, only Java programmers will do that. Yeah. So, because this is the thing that is happening here. There's a thread only waiting. Yeah, it's only waiting for incoming calls. Yeah, it's doing nothing. Yeah, it's just waiting, sitting and waiting. And then it's creating another thread. Who is waiting just for the infrastructure to hand over a data packet to the user and the browser to present that, and so on and so on. And some interaction here from the user will then trigger another very, very small action. And it's waiting and waiting and waiting just for the user to interact. Yeah, and the user is slow in comparison to the computer. And the same here and here. And if we have 2,000 users, we would have 2,000 threads. Yeah, it's completely unbelievable, senseless. So, yeah, what do we do? Yeah, I don't have any time anymore. Has anyone read Stevens? Do anyone knows TCP/IP Illustrated? Yeah, okay. One, Walter. But Stevens, he died, I don't know, 20 years ago. But he writes some really important things down about POSIX standards. And it's just a combination of information. Yeah, it's something that I do here. Yeah, he doesn't invent anything, but he writes it down. And the main thing what I discovered is when they invented POSIX, they invented the idea of select, select, poll, epoll, things like that, waiting for file descriptors. No one. Okay. Yeah. Okay. Some. Thank you. Yeah. You could wait for events. Within one thread, you can wait for multiple events, and that is what ASU does. Yeah, it's just sitting and waiting for events. These are all events, but they can be handled in one thread. It does not make sense to divide that into multiple threading. And that is what I wanted to show here in 6 minutes. Okay, we have this is really a really small example. Yeah, what I only use is sleep. Yeah, I only use a wait state in form of a sleep. You can wait for whatever. Yeah, packets that are delivered by the network layer and things like that. Yeah, but this is the easiest way. So here we sleep for a duration, then we print out something, then we sleep for a duration and print out something, and so on and so on. So yeah, we can call that, and it's doing what we expect. Not really interesting. So, but when we do this, it's this is mostly clear. So when we want to have another process that's doing this in parallel, then this would not work, right? Wouldn't. Yeah, obviously. Yeah, it's handling A and then it's handling B. So what do we do? That is what I showed in the last slide. When I'm a bad programmer, I do something like this here. Yeah, I use threading. Yeah, I use thread A, thread B. I I use different durations so that I can see something, yeah, that is happening really in parallel, and call that, and it's doing my stuff. B A B B A A. Yeah. So yeah, it's in parallel. You can believe me. So, but on which cost? Yeah, what's the cost for that? Yeah, we need 2 threads, and if we want to have another one, we need another thread. Yeah? And if you use ASIO, then this will be gone. Yeah, because then the events are handled just as events in a select, in a single threaded event-based loop behavior. So this would look something like this. Yeah. Thing is, it's a bit more difficult to show. Yeah. Okay. Yeah. I think you can see it from here. Yeah. We need a steady timer. I use steady timers because I like to use start chrono milliseconds. And we need to define a timer, and we need to define a duration. You can set a timer with a duration as well, and we need to define what should happen during this async wait. Not during, but when this timer has what is it? What's the word? When the timer is hit. Yeah, and another thing is this duration must be. You cannot only use the duration x, but you need to define duration from time now, because all these functions will return immediately. Yeah, it would not wait at that moment. It will wait when the service is run. Yeah, it's bound to one I/O service. Yeah, that is an ASIO service. That is nothing else here in this run. I'm not sure if I could say that. So this is a while loop with a select, yeah, or with a poll. Okay, and so when we use this one, what will be immediately be shown is start service. Yeah, that is the last line here. This one, start service, and but this appears in the very beginning, because nothing happens when the service is not started. Question? What's okay? Well, question. So I'm not sure who is familiar with ASIO. Yeah. Okay. Jens, but I think nobody else. Yeah. So I really from the point of a software developer in embedded systems that have the ability to use a full operating system, this is not the worst to think about ASIO with communication or whatever. Yeah, it will always help you to reduce your threads. Ideally, you will not use any threads anymore, because you can do most of the things in one service, and then you don't have to care about things like process to lock variables and things like that, because every function here is guaranteed, because it's one thread, it's guaranteed to be processed in one after another. There's no you couldn't, if you print now, if you use one variable in that time, you can be sure that the variable is only handled at that time from one method here. Question is, what should I do when I need to wait for something? You should not wait for something. It's forbidden. If then the concept is not fulfilled. The concept is, if you want to wait for time, you need to use a timer. If you want to wait for a file descriptor, for a socket, for reading from a file system, from reading from the network, or writing to a network that is not sended everything, then you get an event from the send socket. You declare all this as methods that should be called when the event is sent to the ASIO service. So if you're waiting for a read socket, then you do nothing but say something like, I want to listen to socket XY, and then you are that is only in 0 time, more or less. And then it's like a socket that you say no wait or something. That you can read out from the poll during an event where you see, okay, that socket is now has something for me. That is how poll would work. Select. Okay, does it answer your question? Yeah, it's a different thinking. I do this for several years now, and for me, I did lots of simulation in at the university, and this was all event driven, and so for me it was not so difficult to understand. So I sometimes I have it's really hard for me to give the information to other people, because for me it's really clear. And for, doesn't work. I'm sorry. So this is we are stopped here. I'm sorry. But So conclusion is that I didn't get to the end of the ASIO stuff, but I think we might have the possibility to talk afterwards. So but you're right. You need a full POSIX system, else it wouldn't work.